Good evening to you all. This is the final presentation on my AI project using artificial intelligence to detect and classify cancerous tumors or cells. Starting off with the introduction, the project was established basing on the analysis undertaken, and to discover that during the diagnosis of cancer, the first step is to classify and identify which cells are cancerous and which are non-cancerous. After that, precautionary measures can be taken to deal with the cancerous or benign cells. Physicians sometimes find this difficult because the number of cells in the body is numerous, and accurately classifying all of them in their right categories is a daunting and difficult task. So, cancerous tumors result from abnormal development of cells, and that's where cancer entirely develops from the abnormal spawning or growth of cells in a body tissue. The cells are either cancerous or non-cancerous, benign or malignant, as we can see. The classification, since it's difficult to be done by physicians and doctors, it can be accurately done by a well-trained and stable AI model or machine learning model, which is the main purpose of this project. The dataset we used included features of a numerous number of cells. The field of the properties of the cells we had included the radius, the texture, the perimeter, the area, smoothness, compactness, etc., etc., and the classification on whether they are cancerous or non-cancerous. So basing on these various properties, we'll be able to train a model that can further on classify new cells and see whether they are cancerous or non-cancerous. So already there's a lot of work being done in this field because the impact of AI on the world over has been massive, and nonetheless it has been applied to the medical field. Various engineers have come up with their own models, including that use algorithms such as decision trees, random forests, artificial neural networks, and all of these have one target: to classify cells or to aid in the detection of cancer, in the classification, and eventually the cure. We did a literature review on all this, and it revealed that a combination of many models, and to come up with more accurate and more efficient models, such as the ensemble stacking model, which we also developed in this project. We used various classification algorithms, such as the k-nearest neighbors, logistic regression, and support vector machine. We then combined their attributes or their properties to come up with the stacking ensemble model, which is basically a combination of all the strengths of the three models that we've picked to come up with a more efficient and more accurate model. We used feature importance as our model interpretation technique, and we came to establish that support vector machine had the best results among all the three, but we still went ahead to come up with a more accurate and more efficient model for stacking ensemble. Feature importance, it's a technique that calculates a score for all the input features for a given model. We assign scores to the various properties that are input, such as the perimeter or the area, the concavity. We determine how much do these properties affect the final output, how much does the perimeter affect the decision, the final decision on whether a cell is cancerous or non-cancerous, which feature is more crucial in determining the classification of a cell. Is it the concavity? Is it the smoothness? Is it the circumference? Is it the perimeter? That we further use the Gradio application. It's a software to create interactive interfaces for the model so that we can visualize the data and see more insights from the results of the model. We went through a data cleaning and EDA, exploratory data analysis phase, whereby we removed null values, we remove duplicates, we remove values that, according to the feature importance technique, weren't contributing anything to the final decision. We removed outliers, and yeah, generally it's a stage to clean up and organize the data ready for training and testing on the model. Again, we used a combination of the support vector machine, k-nearest neighbors, and logistic regression to come up with the ensemble stacking method. And the ensemble stacking method, again, is a combination of all these three to come up with a more efficient and accurate model. Model parameters were then optimized and improved. This is in a stage known as hyperparameter tuning. Further, even after coming up with a more efficient and accurate model, we went through a phase known as hyperparameter tuning. We picked out the most important features, and they were optimized to improve the performance of the ensemble stacking method. This is further done to improve the accuracy, improve the efficiency of the model so that it's as accurate as possible. And we did achieve an accuracy of 97%. I think that's an excellent score for a model. The results, the model was successful. It's with a score of 97%, it's fair to say that it's more than capable of identifying which cells are cancerous and which are non-cancerous, and so precautionary measures can be taken effectively. Thank you. That's the end of the presentation. Have a good day.